Have you ever thought of how Singapore will look like in 28 years' time? Will we finally have flying cars by then? Snow in Singapore, or will our jobs be replaced by robots in the future? Well, we will be showing you what the future will really look like in Singapore 2046. For this video, we will look specifically into the environmental aspects of Singapore. First, let's look at the main challenges that Singapore is currently facing. Global warming. Singapore has warmed gradually by around 0.25 degrees Celsius in each decade from 1948 to 2015, which is a rate more than double that of the global average. Being a small and highly energy-intensive nation, Singapore is very reliant on other countries for energy supplies. Global fossil fuel supply is finite and rapidly dwindling, leading to an imminent energy crisis. In fact, most of the world's environmental problems, such as global warming, air pollution, and acid rain, are the outcomes of fossil fuel consumption because of the release of greenhouse gases. Singapore is running out of space for landfills due to increased waste production. Singapore is facing water security issues given the increase in water demand, rising operational costs, manpower constraints, and new challenges like climate change. The Paris Agreement's central aim is to strengthen the global response to the threat of climate change by keeping a global temperature rise this century well below 2 degrees Celsius above pre-industrial levels. With the signing of the Paris Agreement, Singapore will be incorporating other sources of renewable energy, such as solar energy, biofuel, and geothermal energy. Solar energy is an abundant resource of energy. The sun comes up every day. There is more energy transferred to the earth from the sun every hour than the entire world's electricity demand for a year. In the near future, we will most likely be seeing solar panels incorporated into Singapore's infrastructures. Singapore receives about 50% more solar radiation than temperate regions, with an average annual insolation of 1,580 kWh per meter square per year. The electricity generated by rooftop solar panels alone can provide enough energy for common services in more than 30% of public housing and more than 50% of private condominiums. Street lamps will be powered using solar panels, together with motion sensors where they will switch off automatically when no one is around, effectively conserving energy. The rooftops and corridors of some homes in Singapore's heartland will soon be powered by solar panels, and outside walls will be covered with cooling plants to reduce the need for air conditioning. However, solar panels are difficult and expensive to maintain. The solution is solar leasing. Solar panels are installed without charge on otherwise unused roofs or land. The electricity generated by the solar panels is then sold to the property owners at a cheaper price than that of electricity from the public grid. We may expect to see more of vertical farming in Singapore, which optimizes land use in land-scarce Singapore. In the future, with more developments, it will be a challenge to allocate space for agriculture. Vertical farming operates on minimal manpower and has high yield, which will be very essential for Singapore in the future to accommodate the greater demands due to the increase in population. As of 2015, the Pulau Semakau landfill is estimated to last for 36 years, which is why it is important to source for alternative energy before the landfill reaches its capacity. Singapore's main source of bioenergy is waste incineration, which produces steam that drives generators to produce electricity. However, at the same time, the waste byproducts would have to be dumped into landfills. This may not be sustainable in the long run, especially given Singapore's commitment to becoming a zero-waste country. Hence, in the future, there will be wider use of biofuels produced by algae biofuels. Algae can produce about 9,000 to 20,000 gallons of biofuel per acre, which is 10 to 20 times the amount generated using conventional feedstocks such as beet sugar, sugarcane, and cornstarch. Although there may be greenhouse gases emission from the fertilizers used to grow the algae, the use of algae biofuels may still be necessary in Singapore's pursuit to be zero waste. To encourage recycling, reusing and reducing waste, housing estates will have a garbage chute for recyclable materials on every floor. It will not be a rare sight to see geothermal plants in the future too. By tapping on geothermal energy, we are able to have clean, renewable and sustainable energy with enhanced geothermal systems emitting approximately 0.091 kilograms of carbon dioxide equivalent per kilowatt hour. Geothermal plants can be built near hot springs in Sembawang, Pulau Tekong, and Jurong Island to draw on Singapore's potential to generate large amounts of energy due to its high heat flow of 110 to 130 megawatt per meter square. The issue of land constraints to build such plants will require good urban planning and foresight to find optimal locations to build them. Also, noise-proof drilling pads can be used when deep drilling to prevent noise pollution. Harmful gases released from geothermal plants, such as hydrogen sulfide, carbon dioxide, methane, and hydrogen gas, may have a negative impact on health and the environment. The plants can be operated in a closed-loop system to minimize their leakage by condensing the vapor back into a liquid and reusing it in the heat exchanger and injecting geothermal liquids back into reservoir. However, transition from oil to renewable energies will not be easy, since the prices of oil are relatively low as compared to the prices of renewable energy. In addition, national policies and projection growth of renewable energy are based on the assumption of very expensive oil prices and depleting oil reserves. By 2060, Singapore's total water demand could almost double, with the non-domestic sector accounting for about 70%. By then, new water and desalination will meet up to 85% of Singapore's future water demand. The country must ramp up these domestic resources ahead of 2061, when the current agreement with Malaysia expires and when Singapore's water use is expected to double from about 430 million gallons a day now. Singapore launched the Smart PUB Roadmap, a smart water technology, in its move to digitalize Singapore's entire water system to improve operational excellence and meet future water needs by achieving smarter water quality management, smarter work processes, and network improvements. To conserve water, the estate will have a rainwater collection system designed to provide more than 500,000 litres, or 130,000 gallons, of water a year for cleaning the corridors and common areas. Rainwater is collected on the roofs of HDB, filtered in suction tanks, and stored in the collection tanks for use. To reduce social stigma against reused water, such as water from new water plants, campaigns may be pushed to increase the consumer's confidence in new water to achieve water self-sufficiency and reduce reliance on imported water. This ensures water security and sufficiency for Singapore with less consumption of water and the ability to tap on reusable water. It is difficult for Singapore to have a total abandonment of fossil fuels because of its geographical limitations. Instead, a steady and progressive transition of incorporating other renewable energy sources in conjunction with decreased use of fossil fuels will be more feasible in Singapore. Better practices to recycle, reuse, and reduce waste and conserve water will prove to be beneficial for Singapore to achieve its goal for sustainable social and environmental well-being for the many more generations to come.